Welcome to the lesson 13 of Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and today we'll continue with the topic of SysML v2 connections. In this lesson, you will learn what are the ports and interfaces, what are the items and flows, and how to use a special pattern to refine connections at multiple levels of detail. Real components are usually connected via ports. Ports are dedicated interaction points of a component. Think of USB ports. They work regardless of which device they own. This level of abstraction saves us from countless cable types. In SysML v2, ports are structural features with their own keyword. They expose features of their owners without revealing the components behind them. Most port features are directed. They have in, out, or in-out modifiers to denote which way things flow. But here's an important point. Ports themselves are never directed, only their features are. Although it's legal to declare a directed port, it would mean a component emits or consumes ports. That's definitely not your intent. All port features must be referential. Ports only expose things, they don't contain anything. Let's look at our model, which is already extended with ports. Line 14 shows a port definition called harness connection point. We declare it using the port def keywords. We leave it empty for now. Lines 5 and 10 show port usages in our sleigh and reindeer definitions. We declare them using the port keyword. Ports can only be connected usefully if they are compatible. The easiest way to achieve this is by using the same definition, but turning it inside out on one side. This is called conjugation. This is done in line 10. The tilde symbol before the type means we are using the conjugated version. In a conjugated port, in features become out features, and vice versa, while the in-out features stay the same. Once we have ports, we can connect them with interfaces. Interfaces are special connections used only with ports. They enable loose coupling. Components can interact through well-defined contracts without knowing each other's internals. This makes systems more modular and reusable. As we see in line 19, we have interface definition, which is created using the interface def keywords. It looks similar to a connection definition, but its ends are always ports. In lines 20 and 21, we declare the ends with endport keywords. Notice we also use conjugation when typing one of the ends. Interface usages can be created anywhere, inside connections, outside, or even completely independently without any connections. But in this example, we show a especially useful pattern, interface usage inside a connection definition. Line 31 shows how to do it. The syntax is similar to connection usages, but uses the interface keyword instead. Ports are accessed via connections and sleigh and reindeer. This way, whenever a sleigh and a reindeer are connected with a harness, their ports are automatically connected with interface as well. What is still missing is the specification of what should be exchanged through ports and interfaces. This is where items and flows come into play. Items specify what is exchanged through ports, while flows represent the act of transferring it through the interface. Together, they let you progressively refine your model from high-level connections down to specific item transfers. An item is similar to a part, but it represents something that is exchanged or passed around, not a component itself. Every part is also an item in its own right. Items have definitions, but you'll often find it's worth declaring part definition instead. Why? An item definition cannot define a part usage, but a part definition can define an item usage. Let's see how item and flows work in practice with sleigh and reindeer example. Lines 11 and 12 show two item definitions, command and feedback. We declare them using itemDef keywords. They are empty now, but items usually have attributes that characterize what they carry. Lines 6 and 7 show how we use these items inside our port definition. Notice the direction modifiers. Command is an output, it flows out of this port. Feedback is an input, it flows into this port. Remember, on reindeer side, the port is conjugated, so the directions are flipped. Now we can zoom in even further and specify what will flow through the interfaces. A flow is not a connection. It's actually an action that represents transferring an output to an input on the other side. Flow definitions exist, but usages are usually sufficient. Lines 19 and 20 show flow usages inside the interface definition. The syntax is flow of followed by the item type, then from the source to the target. Line 19 specifies that commands flow from the islets command output to the harness loops command input. Line 20 declares similar flow for feedback in the opposite direction. You can also use a shorthand syntax without the explicit type. The payload type can then be inferred from the connected features. Let's put it all together and see how this creates a powerful modeling pattern. Here's a model that combines everything we've seen in the last two lessons. On the entity side, we model at 3 levels. First the parts, then the ports, then the items exchanged through the ports. Lines 3 through 11 define our parts, sleigh and reindeer, each with their ports. Lines 14 and 17 define the port with its directed items. Lines 20-21 define the items themselves. On the connection side, we also have 3 levels. First, the connection definition, then the interface between the ports, then the flows between the directed features of ports connected by the interfaces. Lines 24 through 29 define the harness connection. Inside is interface usage that connects the ports. Lines 32 through 38 define the harness interface. It contains flow usages that specify item transfers. This is a powerful hierarchical refinement pattern illustrated by this diagram. The outer layer shows the connection between sleigh and reindeer. The middle layer shows the interface between eyelet and harness loop ports. The inner layer shows the actual flows, commands going one direction, feedback going the other direction. Switching back to the model, we see in lines 41 through 53 how to use this pattern in context. Line 48 creates the connection using our harness connection definition. When this connection is established, every instance of the connection will automatically contain the interfaces with the flows. You now know the core SysML v2 concepts required to connect your model elements. Yesterday you learned about the connections and special subsettings, while today you learned about ports and interfaces, items and flows, and how to put everything together. Your challenge task is to take the Santa sleigh model from previous lessons and extend it with these new concepts. Add ports and interface to your connections. Define what items flow between Santa, sleigh, and the reindeer. See the blog post for full task details. Share your experiences and feel free to ask questions in the community forum. Links and information how to get access to Syside Cloud are available in the video description. Subscribe to our YouTube channel and click on the bell icon to get notified about future lessons. Take care and happy modeling!